Hi, good evening, everyone. Uh, Hope I'm loud and clear to everyone. You can get in the inbox, you can get in the chat box and you tell me if I'm audible enough. Can hear me? Thank you, Regan. Can confirm. Um, I'm Arfan Kunda and I'm the director Cairo and Cairo Solutions. And on this call, we are having the Mr. Reg Paul and Roniet Kamtewa, the junior chamber at the Ghana Chamber of Mines and Petroleum. This session is meant as to study more about geology and through ArcGIS and a little Python. Um, since it is just the primary weeks or to start, I think I'm going to suggest maybe we can more 5 minutes to wait for the people to join in, or more people to join in, and have these admissions out to the people and to update other people in the group. Shall they maybe started, and in a still we start just in the next 2 minutes we kick off. Um, Even before that, I'm going to share a link which we are going to use to issue certificates to any person who has attended this session. And the link is going to come, we are going to put it in the chat box here, and we are going to drop it out on the WhatsApp. Whoever takes the initiative to register as this is going on will qualify to get a certificate of attendance after this session. So let me drop through the links in the chat box for other people joining, and in the next 2 minutes we should be set and ready to go. Thank you. So, once again, uh, my name is Asana Tukunda. Again, the director for Cairo. I'm the director for Cairo Solutions, and we have organized training in partnership with the Uganda Chamber of Mines and Petroleum. Uh, Basically, it's about heights, the ArcGIS, and we've provided a few resources on the group. Those are managed to access some of the data sets we are going to be using and throughout this entire training. And through that way, I'm meant to give you a brief introduction about who we are and what is new. And through that, we'll bring in my brother, Electrical Francis, who's a solution engineer at this firm, Uganda Limited, who is going to take us through this training, and we will be happy and we will grateful for all the numbers which are coming in, keep updating all the people in the group who are able to join us. So just let me share my screen ASAP so that we can have this out of the way, a brief intro, and then we get going. So sharing my screen. Hope it's visible to everyone. Um, so I can see it's can confirm it's visible to everyone. So who are we? We are Cairo Solutions, and we are a startup company. Next, I think we're celebrating our first birthday in the next 1 to 2 months, and we are a tech and energy company, and our mission is to provide innovative, reliable, and customer-focused solutions that drive progress while contributing to a greener future. And that way, we enhance everything digitally and we provide eco-friendly energy products which can be used by anyone. And we have provided a few like different companies. This is what we offer: tech solutions that include software, hardware, systems, and software. And these where trainings are like these energy solutions which sell LPG products, different university premises, and right now fully based in Cambogo. We do a lot of brand management. That's building brand, doing marketing for the online and the offline presence, and we have pulled out a few, and then we are into corporate event management with one of our recent events which we did for ICTAL, Information Technology Association of Uganda. And we managed to pull off one, and more as to come. Talked about our vision and our mission, and our tagline is empowering tomorrow today. Our core values include innovation and excellency. We talk about sustainability, our customer focus, collaboration and teamwork, and we encourage a lot of integrity and transparency when we are doing all the activities we do and what we deliver to our client. I think I'm going to go through all this. It will take a lot of time. Our manifesto is to innovate boldly, sustainably, and passionately. Together, we create a brighter future for our clients and communities and our planet and the students or to the community we are having around you people. I've talked about this, what we do here. It's a development system development, software sales and hardware sales with one of the projects we are very proud of, the system we have developed uh, I don't know, call it a platform which is incorporated with Lizzy, with Total Energies. This team we are using for the in-house training and the projects I'm very proud of. And some of these other products being provided then over time, we build different websites for different companies. And that way, yes, this is all about gas, sell gas, LPG cylinders, gas refills, and all accessories attached with gas. Then logo designs, corporate branding, and marketing materials, social media management, and brand strategy. This we're doing it, and we provided the service to the different companies we worked with. I've highlighted about the corporate event management, through the physical and the digital webinar, and this is part of it, and the hybrid webinars and events, one of which we are having an event tomorrow under Total and DTS. And yeah, we're proud to provide such things for our services to our business clients. And I think it's something which you can highly recommend us on any other platform. Why you choose us? You know, the mission, customer-centric excellence, commitment, sustainability. We have an expert team of professionals, and some of them you're going to see them. I'm among them, and we provide really, really cutting-edge solutions to the markets. These are some of our clients, and this is a small slide more beyond what is looking at here or seeing here. So these are contacts, and some of our contacts are already on the group. You can access us anywhere. So thank you for this. I think this is a simple brief until now. I'll get my sister Rania, which is on the call, so that we can give a brief info about the chamber and what they do and the services they provide or what they are looking at through this and how they can empower you or the students, the youth, and they're looking at venturing into the energy space or the tech space. It's the right partner. I don't know, Rania, are you there so that you can get on the call?
Yes, Atta. Thank you very much. And we appreciate each and everyone that is on the call. My name is Ronia Chukamhewa. I am the team leader at Junior Chamber, and we welcome you all for this training. So before we dive into today's training, please allow me introduce the Junior Chamber, which is the platform under the Uganda Chamber of Energy and Minerals, basically established to bridge the gap between the young professionals and the extractive sector. Our commission is to empower youth through skills development, mentorship, innovation, and opportunities in the energy sector. So we are glad to work with you, students, graduates, and early career professionals in this industry, and together with the government institutions, the academia, the developmental partners, and our programs literally focus on graduate employability training, internship and apprenticeship, young innovation, youth innovation and entrepreneurship, policy engagement, and advocacy for the responsible development. So we are literally keen on embracing technology and data. And this is why we have such trainings like ArcGIS to help support evidence based on decision making, sustainability, resource management, and inclusive growth. So we are looking forward to have more of these engagements with you, and we hope that you have a fruitful training. On that note, I would like, I don't know if Arthur will give me an opportunity later on to come back. Arthur? Should I just say it all, or you'll give me an opportunity to come back?
Yeah, so if you really want to come back, I'll bring you later on, but I don't mind. You can keep on your around, or you can.
Okay, let me just say it and then I'm done maybe.
Yeah, sure, that's okay. That's okay.
Okay, so I want to invite young professionals, the ones in the early career professionals, the graduates and the students that are coming from regions like Kabale, Gulu, and Toro. We have trainings on dates that will be communicated. We are working together with UNDP. So we invite you to register. Our links will be posted on our different platforms. So please visit our platforms. And if you come from these areas, kindly participate, be part of these. There'll be physical training, so you need to be there, and we welcome you all. Thank you very much. May you have a fruitful training.
Thank you so much, Ronnie. Right, she holds the biggest internship I've seen, and some of the groups we have them and they speak for themselves. We have a few people have been placed up in the town, and few I've seen in SLB, and a few we've seen around, and it's been a very great and great, wonderful. So I'll not waste any more of our time. I don't know whether my brother or are you on the call so that we can have this out of the way and see how people get onto the training. Um, and I'm going to again to share the link about the resources you need. We have shared it on the group, but again, for purpose, I'll put it on in our chat in this call. Make sure that you can get into it and we see how far we can have this field into your life. Thank you. I'm seeing Oraj is live on the call. So, Oraj, I think you can take it on, introduce yourself, and let's get on board with what is for the team today. Thank you.
Okay, thank you so much, Arthur, for the opportunity. I hope I am loud and clear.
Yeah, sure, you're loud and clear.
Okay, I'd like to welcome everyone to this webinar called GeoCode Lab 2025. I don't mind my background, I'm home, so I hope that won't distract people. I will just introduce myself and then turn off the camera and focus on the webinar. So I am a petroleum engineer by training, and as we've been introduced, I am a solutions engineer with Visca Integrated Consulting Limited here in Uganda. I serve in several other capacities as well, but I'll just mention one, that I am also the chairperson of the membership committee of the Geological Society of Uganda, and that mandates me to ask everyone around here to please join the society, and be a part of building the geological history of Uganda together. So that is briefly about me. My skill sets, of course, are quite clear, as if you visited the website that GeoCode has been running, you must have seen the skill sets that I bring to the table. I am glad to see that we have Big Solutions Group in the webinar. I learned a lot when I was with Big Solutions Group as a geoscientist, and I always don't forget to give Madam Amina Mayole her flowers from Big Solutions Group. So without much ado, let me turn off this camera and we focus on the webinar.
Just a quick one on that. I'm noticing that there are some issues with the Google Drive we use to share the resources. I don't know whether you can entirely make it open or there is an issue with someone who's using the computer. So I think try to open up the link so that you can get our video. Thank you.
The link that I shared is open. Anyone with the link can access and download the data sets. So if someone is facing an issue, that should be maybe with their internet or their device or something, but the link is open. So this is what we are going to do. We are going to have an hour and look at ArcMap, and then we shall also have an hour to look at the Python bit. So the first part of the webinar is going to look at the foundations of GIS using ArcMap. I communicated earlier in the group that the concepts we are going to learn today do not require one to have prior knowledge of any of these tools. So whether you've worked with the software before, whether you're a Python coder, whether you're a Vibe coder, you don't have to worry, because whatever concept we are going to share is something that you get to learn in a day if you bring up a learning mindset to the webinar. So the first bit is going to be these foundations of GIS with ArcMap. And we are going to briefly run through the presentation slides, and then we can have a practical session for about 40 minutes. And then we move on to the bit that has Python. Yeah. I hope everyone who wants to follow through practically has ArcMap installed on their machine, whatever version it is, as long as it's stable and it's going to support you through the learning process. And I hope everyone also signed up with GitHub and has an account. It's free to sign up for GitHub. I hope everyone also has a Google Colab account. We are going to use an online code editor, that is Google Colab, because it is quite much easier to set up and it's a free, platform. And then we shall be storing our notebooks on GitHub. So that's why I needed everyone to have a Colab account and then a GitHub account. So without wasting time, we're going to look at digitizing scanned maps, and then we can go ahead and produce a static map. This is a foundational kind of concept that we are going to give. It is to bring you that curiosity to want to learn more. GIS is quite broad. It can be applied in site selection, environmental people can use GIS. You can use GIS for crime hotspots, mapping, and a number of other things, yeah? So let me just move through to the next slide here. Understanding GIS and ArcMap. We understand that geographical information systems, or GIS, are advanced platforms that we use to visualize and interpret data through the lengths of geography. Yeah. So these slides are also going to be shared with you in the WhatsApp group later. after the webinar, so you'll have access to them. I may not be able to read through the entire thing. ArcMap that we're looking at today is no longer being supported by Esri, but it is one of the flagship products within Esri's ArcGIS desktop suite. And it is best that if you want to venture into GIS, you start by learning the very basics of ArcMap. Then you can go on to learn other open source tools like Q, and then you can venture into the web, mapping tools like Files, GIS story maps, and other things. Yeah. So GIS or ArcMap enables professionals to create detailed maps, manage large data sets, and perform spatial queries and everything. So for now, we are going to look at cartography specifically, and the aspect of cartography that we're going to look at is producing static maps. Cartography is the art or the science of map making, yeah? So we are going to have a data set. We're going to digitize something. Assuming you work in the energy sector and you have maybe a minerals map that is in hard copy at your office, and you want to, try to add maybe some data sets to that or communicate a different story with that data. You can have your map scanned, and then you digitize it using ArcMap. Go ahead and add some other data sets and tell a different data story with that. So this is what we're actually going to do. If you went ahead and downloaded the data sets, you must have seen that I shared some shape files, and I also shared some soft copy of maps in forms of, I think, PNGs or JPGs. So those are the very ones that we are going to digitize. I'm going to take you through the process of digitizing a map in ArcMap, and maybe cleaning the data, looking through your attribute table, and then we can produce a map out of that. Yeah. So how do we prepare our, workspace for digitizing a map in ArcMap? Allow me to run through the entire presentation, then we can move to the practical bit, yeah? So we have different data sets in GIS. We have raster data and we have vector data. Now, vector data represent real-world features using maybe points. You can have a well, you can have a tree, you can have an electric pole as a point on your map. You can have lines or polylines. Examples could be rivers, roads, railway lines, pipelines. Those are vector data that we call polylines in GIS. Or your data can be a polygon, maybe a district, a school boundary, a protected area, or anything like that. And then we also have raster data that is made of grids or pixels, like satellite maps, like elevation maps, or even the picture that we're going to use to digitize today. And then when we load, we can as well load base layers. Loading base layers means adding background maps. You can have a map from OpenStreetMap, you can have a topographic map to add some context to your map that you're trying to produce. When we do map making, we're trying to tell a story. We have data sets. Let's say you have population data. You've calculated your population density, and you have the geometry of the maybe districts or sub-counties, and you want to tell a particular story with this data set that you have, yeah? And maybe you want to show how the population density varies from each region of the country, So that is one example of a data story that you can tell with this kind of data. We don't just make maps for the fun of it, that we want to, put it out there that we have made this map and it looks something. Your map has to tell a story. The person reading the map has to understand what you, as the map maker, was trying to communicate. It is not just a science, it is an art actually, because you're given data and you're required to tell a story out of it. And these stories could be stories that inform decision-making at organizations. If your firm wants to maybe look at an area that they want to roll out a project of maybe relief aid or something. So if you tell them the kind of population you have in such and such areas, maybe they're targeting densely populated areas, your map could help them make such kinds of decisions. And then first thing we do when we are, of course, digitizing maps is we have to georeference. What is georeferencing? If I am traveling to Jinja and I want to maybe go to Night Hill and I'm trying to get direction from someone and they tell me, if you reach the Nile Bridge, maybe you drive about a kilometer more and you turn right or something like that. So they are using a physical location on the ground, like the Nile Bridge, to give me direction to Night Hill. That is what we call georeferencing. You're referencing or you're referring a physical feature or location on the ground to something else. So we are having such a picture, this map here that we are having. So it is in a soft copy, and now we want to pick out maybe the license areas from it. This is a status of licensing for oil and gas activities in Uganda. Now we want to pick out the license areas, and then we want to tell a story that says maybe which districts are affected by this, licensing round or something like that. We have to georeference first this map because it does not have the spatial information that can be projected on a map canvas. Yeah. So georeferencing is a process of assigning real-world geographic coordinates to a raster image. Images are raster data in GIS, such as maybe scanned topographic maps and blah, 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 and all the rest. So the core of georeferencing is establishing control points. Now, for you to be able to digitize your map in GIS or in ArcMap or whatever other tool you could be using, you need to establish what we call control points. Your map has to have grids, and then these grids can inform which control points you pick for your georeferencing. We are going to see all this practically just as soon as I'm done with, running through this presentation. Digitizing spatial features, of course, we can digitize points, we can digitize lines, we can digitize polygons, If you remember very well, maybe in high school or in primary school, where you used to be given a hard copy map, maybe of Kenya or Uganda, and you're required to digitize it, you would have, I think, something called a tracing paper, and then you would somehow put it in your book, and then you start tracing the outline of this map. Now, digitizing is a similar thing, but here, the only difference is that we're doing it digitally or using a software. You have a map and you're trying to trace it on the actual ground, So if you see here, digitizing is the process of tracing or drawing spatial features like points, lines, polygons on a map using a reference image or a scanned map as a guide. Yeah. Now, please mute whoever is, not muted. Please mute. Okay. Please, if I am going so fast, you will let us know in the chat. But since this is just the bit of the slides, I think it's okay. But when we get to the practical bit, if I'm going so fast, you'll let us know. We're trying to beat time. We want to give you as much background information as possible, but we also don't want to waste a lot of time on it. Yeah. We're also going to look at how we can edit attribute tables and maybe play around with the data in ArcMap. We shall also look at how we can do the same in Python when we get to that other bit. Yeah. Don't worry, these slides will be shared with everyone eventually, and then you'll get to see. So map styling. When you want to put out your map for, let's say you're working for the Petroleum Authority of Uganda, or you're working for UNOC or whatever, Ilembe Mines or something, and you've been tasked with telling a story with the data that they have. How do you symbolize your map? How do you do the labeling? How do you, make sure this map is not only visually appealing, but it tells a neat data story? So there are rules to cartography. There are rules to map production. You don't just pick colors out, If I'm trying to represent grass or grassland, I can't use a blue color to represent something that is actually green on the ground. So you have to have the actual colors represent the actual things. If I'm looking at a lake, I can't say I'm going to use red to represent my lake. It has to be blue, of course, to represent the water or something like that. So you should, at the back of your mind, consider all these rules. If you want to learn more, you can just Google and say, what are the best practices when I'm producing a map, as far as symbology is concerned, as far as labeling is concerned, because you want to bring out a map that clearly highlights what you want the reader to see, and then let the other things not be so noisy on your map, if I should use that word. And then we have designing your static map. A static map is simply, how should I say, something static, it's just like you're seeing this screen. It's not interactive. I can't, toggle on and off something. So we are going to look at this, designing your static map in ArcMap. We're also going to do a static map in Python and an interactive map. Now, an interactive map is one where maybe if I could probably click on maybe this Masindi polygon, it would pop up and show me what the geometry is, the coordinates or something like that. That's what an interactive map is. But a static map is just basically what you're seeing, nothing interactive on the page at all. Yeah. So how then do we go ahead and, export our maps after producing it? Depending on the purpose for which, you are producing the map, whether it is for a journal or maybe it is for a magazine or for a website or something, that also matters when you're producing your map. You should make sure you produce a map that has very high DPIs or dots per inch, I think that is it, yeah, dots per inch. So the resolution should be very good. If you're producing maybe a map that is going to be printed out in hard copy, you should consider all those. And next and further steps, of course, you've heard that Shiro Solutions organized that webinar together with the Junior Chamber of Energy and Minerals. So they will not only stop at giving you this webinar, they plan to roll out more tailored or custom-made training solutions for your individual needs. You just have to reach out to their team, and then they get to tailor a solution to your specific needs. As solution engineers, whatever problem you throw at us, we make sure we find a solution to it. So basically, don't get discouraged that this is the only webinar you're attending. Should you need to learn more, you'll reach out to their team. They are planning out, a number of other very good courses or training programs, whether they are one-on-one, whether it's for your entire team. All you have to do is, reach out to them. So by the end of this first bit of ArcMap, you would have mastered essential ArcMap workflows, from digitizing a map to producing polished static outputs. And this foundation will set you up to tackle more complex GIS challenges with confidence. And don't forget that the geographic approach to problem solving is about seeing the world holistically. As engineers, we could have very many, ways of solving problems. But if you look at it from a geographic perspective, and so you have to view the world holistically. And you probably, after this, whether this is your first time hearing about GIS, or whether you're a seasoned cartographer, or spatial analyst, or data analyst, just take a leap and dive into advanced spatial analysis, geodatabase management, web GIS, and you could unlock the full power of geographic information systems. And I've already mentioned that you can, reach out to Cairo and the Junior Chamber to elevate your skills and learn a lot more other things. So allow me to switch now from this. We are going to follow the flow of the presentation the way it is. I'm going to take you through how to load data sets. Then we can go ahead and georeference, digitize, produce our map. Just briefly, it's basically demonstration. it will not take very much of your time, and then we can move on to, the next thing. I don't know what the team is planning around questions. Maybe you could throw in your questions in the chat as we go on, or maybe there will be a question and answer session later at the end of the entire webinar. Let me present another thing. Okay, I hope my screen is visible to everyone.
Yeah, sure, it is.
Good. Okay, so this is the interface of ArcMap. That is how it looks. And so if I just take you through the entire, interface briefly as we start the webinar. All right. So this is something that I was working on to prepare for, this particular webinar that we're having right now. Just like any other software that you've worked with before, we have, whether it is Word or Excel, we have a file menu here. On the menu bar, we have the file where you can open a new file, where you can open a file that you've worked on before, where you can you save as, and every other thing. We have the edits and the edit options that are there. The view now helps us to switch between the data view and the layout view. Now in ArcMap, the data view is where we get to manipulate or interact with our data. And then in the layout view is where we get to now produce our map from. Add things like a title, a scale, a legend, and every other thing. So what you're seeing on your screen right now is the data view. Yeah. Of course, the insert is when you're producing your map and you're trying to, add a legend or the key, the north arrow, and every other thing. Selection is there, geoprocessing. I'm assuming that the people that are part of this webinar have some background knowledge about GIS. So please don't mind if we rush through everything. You have already heard that the Gyro Solutions intends to give you a better training after this webinar, as long as you reach out to them. So we have toolbars that we can use here. As you can see, we have draw, we have georeferencing, we have layout, and every other thing that you can see there. And we also have windows and help and every other thing. So now you can open your ArcMap and we, start on an entirely blank map, and then get to learn from the very basics, of everything, for those who are following through, of course. So you're going to go and connect, first of all, your folder. If you look at the top left, you'll see the title is saying Untitled ArcMap. What do you do before you start any project in ArcMap? You have to name your project. So I am going to name mine, maybe, let me go to Save As and say I want to save this to my maps, and I'm going to name it GeoCode Training. That is going to be my project. And then I save. So now my project has been named, and it's now called GeoCode Training. Yeah. We're going to go ahead and if you look under your windows, we have a table of contents, which is this that I've toggled off. So if I just want to turn it back on, I can turn it back on from there. We also have a catalog, which is very important because it has our folder connectors and every other thing. Okay. So what you're going to do is you're going to go to your catalog. As you can see here, where my cursor is, that's the catalog. It will pop up on the right. So there is this envelope with a black plus sign on it that says connect to folder. When you just click on that, it gives you a dialog box where you can, scroll through and look for which particular folder you are trying to connect to your map project. Now, in this case, we have GeoCode. That is what I called my folder. So it's what I want to connect. So I'll just say, okay. And that GeoCode folder is now connected to, my project. If I expand, I am able to see all the other subfolders that I have within that folder of GeoCode. And so we want to digitize a map. So I have a folder that I named maps to digitize there. Okay. So you just drag. It is very simple to add data to, your map canvas in ArcMap. One of the easiest ways is after you've connected your folder, you just drag and drop. So if I drag and drop, I get that dialog of unknown spatial reference. Of course, since this is a raster data set without spatial reference, and we're just trying to georeference it and get to digitize it, so it will have no spatial reference. Just say okay, and that is fine. So if you can see on the map that we have just imported into our canvas, we are having a map that has been titled The Status of Licensing for Oil and Gas Activities in Uganda. And you can see we have, if you, I'm assuming on your machine you're also doing the same. So if you look at the legend, the line that's the polygons with a blue line, those are production licenses or license areas. The ones with a, is it purple? Oh, those are exploration licenses. And then we have the green, with a purple boundary. Those are pending surrender of license and so forth and so forth. So at the beginning, we said you could have such a data set and you maybe want to pick out something particular from it. If you perhaps maybe just wanted the shapefile for Lake Albert, you could digitize just that and have that only, for your map. So for the interest of time, I am just going to show you how to add control points, how to go ahead and edit and come up with new shapefiles for the digitized data sets that you're having. Then I'll go back to the project that I already worked on and we move on from there, But as you can see, this particular map that I have here does not have grid lines. Well, it does have grids and they're labeled clearly, but the grid lines are not there. Yet we very much need grid lines to be able to determine which control points to use, for our digitizing. So what do you do? Now, this is where your problem solving skills come in, the very basics of problem solving. I need control points, but I'm not seeing the grid lines here. What do? Take this map into maybe an image editor software, maybe if it's the photos app on your machine, the 3D whatever on your machine, and draw clear, grid lines from this, maybe here. Sorry, the line is not straight, but I'm just trying to demonstrate something. If you're drawing a grid line, you'll have to draw a straight grid line like that, so that they can, have somewhere where they intersect. You follow, if this is the first grid that I have, there's another one that corresponds to it down here. So you draw a straight line from the upper one to the downer one. The same thing from here to here. What we are trying to achieve is we are trying to achieve points of intersection between these grid lines. If I can have one here, another one maybe somewhere here, another one maybe somewhere here, minimum of 4 for us to be able to establish control points for our, map. Yeah. So I did this on purpose. I did share a map without those grid lines on purpose to test your problem solving skill as an engineer or maybe a student engineer out there and see if you're going to be able to, draw those grid lines and come up with them. I am not going to draw this right now. I have one that I've already drawn. So I'm going to remove this and import one that has those grid lines clearly drawn. But for your case, since yours is not drawn, please do draw it and then come with it here on your map canvas. Note that I have picked the one that says status of licensing for oil and gas activities in Uganda, not the other one of discoveries in the Albertine Graben. The one of discoveries I shared a file that already has those grid lines that I'd already drawn. Okay. So I'm just going to go ahead and remove this and bring one with the grid lines. And it's what we shall use. Upper. Okay, so let me check out this. Where did I put it? No. So is it this? No, this is not it. Just let me check. I hope as I'm trying to get mine, you're taking that time to, draw your grid lines on your map. Okay, see where I have it. Okay, so yes, this is mine that already has those grid lines drawn. So as you can see, what I was saying is you need to, establish your own grid lines here. I already have mine that I have drawn. If you can see, the grids are in a form of degrees, minutes, and seconds. So you have to draw a grid line from this to this, and then one from up here to another one down, so that we can achieve these points of intersection that are going to be helpful in determining our control points. Yeah. I hope we are moving together. I don't see any comment in the chat. Someone is saying, I think we actually need recorded data for this training for everybody to practice in the future. Yeah, the webinar is being recorded. I think they'll share the recording later. Okay, so if you're not, if you're lazy to practice now, well, you can sit back and wait for the recording and you can practice later. Okay. So now that we have our map with the, grid lines properly drawn, what do we then do? We go to customize and we turn on a toolbar called georeferencing. Mine is already turned on, as you can see. So if yours is not turned on, that is what you will have to go ahead and do. And then we can now see that the georeferencing toolbar is here, and what I'm going to georeference is this picture that I just imported. But then what am I trying to georeference on? If you remember the example I gave at the beginning, that we are trying to trace this map onto the actual ground, but I don't have something for, to represent the actual ground that I actually have here. This is where now the other shape files that I shared with you come in. So you'll also go to your GeoCode folder that you connected and you import, the districts 22 shape files. That shapefile is containing all the districts of Uganda, sorry. Just wanted to zoom this to layer. Okay, so we want to trace or digitize the other image onto the actual location on this map that we're seeing here. Yeah. So you will have to determine, what CRS system to use. A CRS is a coordinate reference system. So you have to understand what all where exactly Uganda falls on the globe, between which, longitude lines and everything like that, so that you can know the exact CRS. But the common CRSs that are used for local mapping is the WGS 1984. I am still assuming we do understand GIS, and this is not our first time to interact with the platform. So we have to come to layers, right click and go to the properties. And then we edit our coordinate system here. There are two types of coordinate system, the geographic one and then the projected one. So we are projecting this onto the map canvas. So we use the projected coordinate system, the UTM, or the Universal Transverse Marketer. We have not looked at datums. We have not looked at, all those other things because of the assumption that this is not our first time interacting with ArcMap. If you need to understand the in-depth basic knowledge of GIS, you will attend the training at Cairo later. But then you go to WGS 1984. Uganda, the biggest part of Uganda falls in the northern hemisphere. So you pick out, the zone, which is 36N. Uganda falls between the 36th line and the 37th, north of the equator. So that is the CRS that we pick, WGS 1984 UTM. The zone is 36N, and we say, okay, once we've done that, then we can go and now add control points to our, image that we have here. So on the georeferencing toolbar, you just go click on the add control points, and then you come here. Notice that we said the grids are in form of degrees, minutes, and seconds, DMS. Yeah. So you'll have to just do one click, one left click at that intersection, and then one right click, and you can input. If your grids are in terms of, longitudes, eastings and northings, you input X and Y. But since ours are DMS, degrees, minutes, and seconds, we input degrees, minutes, and seconds. Now, which are the longitudes? The longitudes are the lines that run, vertically, and then the latitudes are the ones that run horizontally. Now you pick out what value of latitude you have at that point. Sorry, which value of longitude you have at that point. So we have 30. And then we have the minute is also 30, and the second is 0. For the latitude that we have at that point is this. We have 2 degrees, 30 minutes, and 0 seconds. So we also go ahead and edit that. We have 2 degrees, 30 minutes, 0 seconds. Now, for the longitude, it is 30 degrees, 30 minutes, and 0 seconds east. So you have to make sure you've indicated east here. For the latitude also, 2 degrees, 30 minutes, and 0 seconds, but north. Okay. And then you say, okay, I zoom this back to layer, and I go ahead to add another control point. You have to add the control points in an organized way. Yeah? If I've started from this as my first one, the next should be this, and then I follow, clockwise. If I'm going anti-clockwise, if I've started this as my 1, then you come to the next one here like that. You have to follow an order, a pattern properly. So I'm going towards the right. So I'm going to put another control point at this other intersection that is here. Just a single left click, a single right click, and then you input the DMS. So we have 31, we have 30 minutes, and 0 seconds east. And then we have for the latitude, which is this 2 degrees, 30 minutes, 0 seconds north, and we say, okay, yeah. If I zoom this back to layer, I can see that now this image has started, to be placed directly onto the map that we have for Uganda. But you can see the image is behind, since we have in our layers here, the Ugandan, the district 22 layer is on top of the image. So I just have to bring it back down so that the image is on top. And I can go ahead and, add several other control points that way. Yeah. But for now, I am going to stop at just the 2 control points, and I can now maybe start to show you how to digitize one, element. Let us look at this license area that was given out to Amar Energy in 2017, the Kanywa Taba license area, which is 344 square kilometers. So what do? Now we go back to our catalog and we pick the folder where we want this new shapefile that we're going to create for that license area to be. Yeah. So since we are working with the GeoCode folder, I would want my new shapefiles to be inside that folder. So you just do a right click on it, you go to new shapefile. So I'll have to name it, since this is an exploration license area that was given to Amar in 2017. Maybe I could just call it Amar Energy. The feature type, this is going to be a polygon. And then you can edit the coordinate system to match the coordinate system of your project, So you just go to 36N and I say okay. And I say okay again. Now we have created a new shapefile where we want to store the information that we're going to digitize out of this map. Yeah. So I go ahead and now turn on my editor toolbar. So if I go to toolbars, I look for the editor toolbar, which is this, and I turn it on. Yeah.
All right.
Yes, please.
Appreciate it here. I think you've not shared your whole thing. And I think some people are missing a few components of what you are actually doing.
Mm-hmm.
So I think maybe you've shared a certain tab. And I think I advise you can share the whole screen like that. Maybe a few pop-ups which come out, or menus which may be going out of the screen you're having. You can all have them in one place. That's in one presentation. Thank you.
Oh, okay. I'm not seeing a screen. All right. Let me see if I can share the entire screen, because I'd only shared the window that has the arc map. So. So I am now sharing my entire screen. I don't know is it now clear, Arthur? You just confirm that you can see the screen with my, arc map. Arthur? Okay, I'm seeing the thumbs up. Oh, so. All right, so we can then proceed. We have turned on our editor toolbar, which is here. And we're going to go ahead and start editing, yeah? If I click on start editing, I pick the new shapefile that I just named, which is Amar, and I click OK. And that is supposed to automatically open for me my create features, that window for create features. But if it doesn't automatically open, it is up here on your editor toolbar that you would have opened. There is this icon that has, I think, like a book and a pencil. So that is what you'll click on to turn on your create features section. And now I'll pick that Amar, and I pick a construction tool. If I want it, if it's going to be a rectangle, you can pick a rectangle. If it's a circle, blah, blah, blah. But since this is a polygon, I'm picking a polygon. And then I'll come here and just trace out, do single clicks like that on the corners of, the polygon, like that. Like that. And then once I get onto the last one, I just do a double click. And I now have that traced out. Now I have to go ahead and save this shapefile that I just traced out. So I'll go to my editor on the drop down, and then you can either click save edits or you just click stop editing. If you click stop editing, it is automatically going to ask you, do you want to save your edits? And I'll say yes. Yeah. And now I have this edit saved. And if I turn off now my image, the one of the GeoCode 2025, you can see that clearly. I have this, that rectangle now directly onto the area where it falls on the map. You can see this somewhere here. If I now edit and change maybe the fill color to no color, maybe just for demonstration purposes, I want the boundary to be red, that, and I say, okay. So you can see we have traced out something here, which was initially on this, You can see the difference if I just toggle on and off this image that we had. We have neatly traced out whatever we had down there onto this. Yeah, we've created a new shapefile from that. So that is basically how we georeference and then how we digitize, different features on maybe a scanned map that we had. So I could now go ahead and digitize each and every one of these production and exploration license areas, and even, the discoveries, the green ones are the discoveries that we have, You could go ahead and digitize all that. You could go ahead and digitize the Lake Albert and everything. And now you go to edit and add maybe other things that you need on your map. I hope up to that point, we are still together. Now allow me to show you how we can edit a few things on the attribute table of, the districts layer that we have. If I just turn off everything else and I remain with only, since these control points are a bit distracting, I could also now turn them off. There is this view link table here where I can just simply, turn off everything, and those control points are gone. So now if I open the attribute table of the districts file, this is the attribute table that I have. You can see that the data that is being used to draw that map that you're seeing has a column called shape, FID, the F15 regions, DNAME, but you can see these are a bit abstract. You don't really understand what means exactly. If I look at F15 regions, what are F15 regions? If I look at DNAME 2016, what is DNAME 2016 and the rest? So I could, go ahead and edit and change the names of the headings of these columns by just simply doing a click on any of the column that I want to edit, and then I go to its properties and I change the alias. So the alias, the DNAME 2016, is in this case what that district was called in 2016. District name 2016. We know our government is funny and is constantly bring up new districts. So district names have been changing over the years. That's why this data is looking like this. So you could just, change this to something that is more understandable to you. If I want to call mine maybe District 2016 to make more sense to me, and I apply, now that column changes to District 2016. The DC 2017 is like the district code in 2017. District codes, I think, what NGOs use to, identify districts. If you look at vehicles from local government, if you see maybe 105, that means that district, that vehicle is from Masaka on their number plate, of course. If you see 323, that's from a Lebtong and blah, blah, blah. So that's what these district coordinates mean. So you can go ahead and edit all this, headings to something that makes more sense to you. And now, what if you want to edit, the actual data that is within the columns? You will have to, go to the editor toolbar and start editing. But now this time around, you will pick the shapefile that has that information, which is the District 2022 shapefile. And you say, okay, yeah. Now, if I go back and open the attribute table, if I want to maybe change the label for Masaka to a capital letter, now I can go ahead and, change everything to Masaka and have it in uppercase. I can change the table and have it in uppercase like that, Busia and have it in uppercase. But this can be quite hectic. If you look at this data, it's quite a lot. You cannot go ahead and change everything like that at once until the end of your data set. So that is where tools now like Python come in that can easily automate and turn everything to uppercase at once. But that's basically how edit information within an attribute table in ArcMap. So once you're done with editing whatever you wanted to edit, you just go back to editor toolbar, stop editing, and it asks you if you want to save your edits, and you will say yes. And those edits are also saved. So now, assuming we have, gone ahead to digitize everything that we wanted from this image, and we have them ready, and now we want to produce the map, what do we do? I mentioned earlier that I would just demonstrate how to do it on this, and then I can go back and open the project that I did earlier that already has those things edited or digitized. And then we can switch and work with that. So as you can see from here, I already had a base map added. Let me first remove that base map. So this is basically what I have at the end of whatever I wanted to tell with that data. From the Districts 2022 shapefile, you can see I only picked out a few districts that are affected by the license areas. We have Bulisa, we have Masindi, Hoima, Kikube, Kagadi, Mtoroko, and the rest. Those are the only ones that I picked out. I also have this Lake Albert is also digitized, so I just digitized it, as you can see. I toggle it on and off. And all these other exploration and license areas that I digitized from the other side. For a one-on-one training or a better GIS training, you will probably, of course, learn how to, clip or pick out only the districts you want from the shapefile that you had, and then you come up with something like this. Yeah. So now, assuming you've done all that and you have the shapefiles ready and everything is ready, and you want to produce your map, everything is ready, all those things you wanted to digitize are out. Remember, with whatever data we are presented, we try to tell a story. The simple story we are trying to tell here is which districts are affected by the licensing rounds, where do they fall? So that maybe if the government wants to make a decision on who should get compensated, they now know which districts fall in this licensing rounds, and they can also know which areas exactly, what parishes, what villages. Of course, if you had a villages shape file, you could also produce that and everything. So let's go and see how we now can produce this map. This was the data view where we are handling everything, manipulating our attribute tables, shapefiles, and everything. So to produce the map, you go to the layout view, which is this. So allow me just delete these ones, and then I show you from the start how to, do them all. Okay, so this is what we have. A meaningless drawing, of course. Doesn't mean anything right now. There are no labels, there's no key, there is no nothing. So you have to add a frame, first of all, to your map. If you know that the features of a good map from primary school or secondary school, a good map should have a frame, should have a key, should have a north arrow, should have, a scale, and every other thing that you were told in primary school that your good map should have. But you also want your map to not be so shouting and everything. You just want to bring out the things that make meaning to the story you're trying to tell. Yeah. If you can see, I adopted the same colors for these polygons of the license areas from the image that we had, but it is advisable to pick colors that will not be shouting and that will definitely, of course, make meaning. Yeah. I have district boundaries in some shade of gray, I think 80% gray or something. The Lake Albert shapefile, of course, it's blue. Water body by default should be blue, and these other things. Now let's begin to add a few other things to our map. Let's say I want to add maybe a base map first, and I go to, there is this brown icon with a plus sign on your toolbars, and there is a drop down to it, the one that says add data. Yeah, it's where you can add a base map from. So I can now pick a tile that I want, whether it's OpenStreetMap, whether it's a topographic, National Geographic, it's a gray canvas, or any other thing that I want to add. Yeah, assuming I've picked OpenStreetMap. This is just for demonstration purposes only. Yeah, and I'm trying to add OpenStreetMap as the best map for this map. Yeah. So as you can see, now I have OpenStreetMap on my map. Yeah. This is just for demonstration purposes. Have it at the back of your mind that your map should be able to clearly bring out the features that you want to bring out and leave the other ones back to not be so shouting. But just to demonstrate to you, this is how we add a base map. You can see just by simply adding a base map, we have already changed the way, or the preview of the map, the way it looks much better than it was without a base map. Yeah. And then how do we add a title and every other thing? You come to insert still. You can insert a title from here. You pick an appropriate and descriptive title for your map. If mine are license areas, assuming that is it. For whatever label that you're going to include on your map, you have to be consistent with your font style or font type or font size, So if I have picked to use maybe TW Cent for my font type, I want to make it bold, the size is that, and I say okay, and I apply. So now my title is going to be license areas, but you have to pick a proper descriptive title, one that is not too short and not too long, but speaks to the reader. And then you can go ahead and add a north arrow. It is not a must that you should have a north arrow on your map always, except if, the audience that is going to be reading that map is not familiar with the geography of that area. Of course, now if someone from China is reading this map, they are not aware of what the orientation is, and they can't tell where the north arrow is or what. So I'll definitely go ahead and add a north arrow for this map, but it doesn't have to be so big or so shouting. It could just be a tiny north arrow down there, and that's it. You add good practice also tells us to give credit to where you got that data from, you know. So you should always have a service layer credit on your map, clearly stating where you got that data from and everything. Yeah. So now here I can go ahead and name whoever I want to credit for this layer. Since I got the map I digitized from the website of the Petroleum Authority of Uganda, I can credit POW. If the shapefile for the districts 2022 had some data from the Makerere geography department, I can add MOOC geography department, and every other person I want to credit. Still keeping in mind that I should be consistent with my font style and font type and everything, Okay, let me just go to frame. I could have a background for the frame to make it look neater, So that's how you come up with those backgrounds for the frames. I'm just basically demonstrating how you can add all these features on your map, Now I have service layers also clearly. Service layer credits clearly here. That, of course, the base map I'm using is from OpenStreetMap. It's there. And its contributors. We also have CCPU or whatever that is that came with the dataset for the base map. I have added, of course, MOOC geography department. I've added the Petroleum Authority of Uganda. I didn't put a comma properly there. So you should have, those credits. You should credit where you got your data from. For legal reasons, of course, that you don't get sued that, A, you've produced this map and the data belongs to us. You've not created us or something. You can go ahead and add several other things. The one that is tricky is the legend. And as you can see, I have, a number of things here. But you get to pick only the ones that should appear on your map. If I want to have the production licenses appear, I pick one. If I want to have the, exploration licenses appear, I also pick one. So I'm only keeping the one that is for Ranto, which I'm going to rename and change it to exploration area. Then the other one, I'm changing it to, a production license area to keep my legend neat. So I keep saying next. You can change the title from here, whether you want to call it a legend or you want to call it a key is up to you. Be consistent with the font style. It's good practice of cartography. Keep saying next. If you want to add a border to your legend, add a background. I want it to be white. To next. And then I finish. Now this is what my legend looks like right now. But I don't want to, if we are looking at boundaries of places like districts, villages, international boundaries, we can't have them as polygons. As you can see right now, the district's boundary is a polygon that is black in color, but I want to change that. Boundaries should always be lines because they are lines. So I go ahead and convert I convert this to graphics because I want to edit the, the legend. I ungroup it. Once I have ungrouped everything, I will delete this that is saying districts, and I'll just draw a line. I don't have my draw toolbar on, but I can go ahead and turn it on, and then I pick a line from here, and I come and, draw one, since district boundaries are lines. It's a bit crooked, but since I'm just trying to demonstrate, that will do. So you can see that black line now represents district boundaries. You know, you have to be consistent with the, of course, naming of the every other thing. I want to change, this is not official, these ones represent production license areas. So I would want to have that consistent. This represents exploration license areas. And so forth. And then you can go ahead and, you know, maybe group them back. And then you organize, of course, everything neatly on your map. And so on and so on. If you want to add maybe who is the author of this map, you know. If the author was Arthur Natukunda, I can put that as Arthur Natukunda and place it somewhere appropriate as the author. If you want to insert an image, you know, you've seen maps with the logo of the Petroleum Authority of Uganda or any other organization that owns the data, then you add a picture. If maybe I wanted to add this logo that I have here, I can just go ahead and reduce its size, also place it somewhere appropriate and so forth. So that is how you know, work around producing your map. Once you're done with everything, you go to your file, export map. You pick the resolution should, you know, be something that serves the purpose of the map that you want to produce. If it's for a website, pick the appropriate resolution. If it's for, you know, a magazine, choose an appropriate resolution. All this information can be Googled. You can just Google and say, what would be the appropriate resolution for a map that is to be used in a magazine, you know? And then you do that. Then you pick the appropriate save as type. If you're saving it as a TIFF, a PNG, a GIF, a JPEG, and everything. You can even save as a PDF and so forth, you know? I want to save mine as a PNG. You pick an appropriate folder where you want to save it, and boom. So this already exists. I don't want to change. I want to call this 2025 just for demonstration purposes. And then you save, you know, and you're done with that. Yeah. So at the end of the day, you have your static map properly produced. And now I want to switch and go to the other bit of Python. It's already 5:28. This is done. I hope we have learned something on how to produce static maps. We have just done everything for demonstration purposes, you know, and good. I don't see anything. I see someone saying, so that ArcMap is connected to online resources. Yes, if you want to add a base map, your ArcMap definitely has to be connected to the internet to add a base map, yeah? It has to. But if you don't need a base map, then you don't have to be connected to the internet. You can do every other thing with the internet, okay? I hope I was not so fast and people were able to learn something. Now we are going to, someone raised the hand. Arthur, maybe you should guide on at what point do we begin to take questions and so forth? Do we take them as we go or we wait till the end? Arthur, are you on?
No, I think let's wait until the end. I've seen some people raising their hands. At the end, what is the program we have? We have the Q&A session. So currently, let's wait until we are done with the two trainings, and then with the two topics, and then we get to the question. Thank you, guys.
So, okay, so let's move on to the other bits of the webinar. We were looking at how we can use, ArcMap to digitize a map and then tell a story from this. So now, as an engineer, after you've learned how to digitize your map, of course, you can go ahead and apply the knowledge to whatever field you're in. If you're a water engineer, if you're a mining engineer, if you're a public health person, if you're a doctor, if you're what, find a way of applying the knowledge now to the sector that you're in. This is not all about the energy or the oil and gas or anything. You can apply this knowledge to whatever sector you fit in. As long as you have the data, as long as you can tell a story with it, it is all about problem solving. Good. So I'm going to share my screen again and take you through another bit, which is now Python. For this, I hope everyone had signed up for GitHub and they have an account. And then I hope you've also, signed up for Google Colab. Of course, you have to be connected to the internet to be able to use Google Colab. So the next bit of our presentation is about using Python. As you saw, it's quite hectic, going around using ArcMap to edit each and every data that we have here. If you want to change information in the attribute table, if you want to write a GeoJSON file, if you want to write or save something as a shape file and everything, yeah. It is much easier in Python than, the other side. But Python is not the only tool that we can use with GIS, but it is one of them very powerful ones. There are other programming or scripting languages that can be quite adept with, spatial data or geospatial data as well. We have ARA, we have several others, but for this, we're focusing on Python. So Python has a number of libraries that you could use, very powerful libraries. With the first one being GeoPandas that we can use to, GeoPandas is a specific one for geospatial data, but the actual library is a pandas library, So GeoPandas was just built on top of the pandas library to aid with analyzing or working around geospatial data, yeah. So in this particular section, we are going to look at how we can harness Python's powerful GIS libraries for insightful spatial data visualization and compelling cartography. Still, we are in the line of map making cartography. We're not going into the details of spatial analysis and every other thing, yeah? So as you can see, I'm the speaker, all right, Paul Francis. I like to refer to myself as a top problem-solving voice. Okay. I'm still going to run through the presentation like I did with the previous one, and then we move on to the practical bit. So why Python for cartography? Before we pick a tool to, solve our problem, we have to understand why are we trying to use this particular tool to be the avenue for solving our problems. When you use Python for your cartography, you unlock the power of automation, for repetitive GIS tasks, streamlining data processing, and map generation. So you can as well use Python within ArcMap, by the way, but that is for more advanced, more skilled or more advanced engineers in the field, yeah. And there are quite a number of code editors that people could use to, edit your Python code so for more adept people, you could use VS Code, you could use Casa and a number of other things. But now we have this online tool called Google Colab that is quite a good, code editor also. So you could use Jupyter notebooks in Colab. You could have direct Python files and every other thing in Colab. And then you get to save your work on GitHub, Since Colab does not directly save your data sometimes, it is good practice to save whatever work you do on your GitHub so that you can always control the versions of the different code snippets that you have. With Python, you also ensure reproducibility in your cartographic projects, making your analysis consistent and shareable through scriptable workflows. As you saw in ArcMap, and when I was trying to show you how to produce your map, and we are trying to edit, the legend, want to put it here, want it to look this way, you could have one script, Python script, that will always produce a consistent legend for you. Now that is what the reproducibility is. So that whatever map you produce is consistent across your work. That becomes the signature of what you produce as an engineer or a problem solver that uses geospatial tools. You can also achieve scalability in handling large geospatial data sets. When it comes to data cleaning, when it comes to inspecting your data and everything, you could use Python. You gain greater flexibility and customization compared to, the graphical user interface driven traditional GIS softwares like ArcMap and Q and the rest. You can leverage Python's extensive data science ecosystem for advanced analytical capabilities beyond standard GIS tools. I would want you to clearly state in the group if I'm so fast, because I'm racing against time and I don't want us to go beyond the set time for this webinar. That's why I might be racing. So what are the key libraries for your cartographic toolkit in, Python? I already spoke about the GeoPandas, which is efficient in handling, manipulating, and analyzing your geospatial vector data. You don't only work with vector data in Python, you can as well work with raster data, but for today, we're only looking at vector data in Python. We have Matplotlib, which creates high quality static maps for publications and reports. The other side in ArcMap, we looked at how to produce a static map for maybe a publication or a report. But in Python, there's a library called Matplotlib that helps us to, work around that. Then we have another library called Plotly for building rich interactive web-based maps, which are ideal for dynamic dashboards and everything. Then we have another library called Folium that leverages Leaflet to also generate interactive web maps that you can directly embed into your web applications or maybe on your website or something. We also have another library called Shapely for geographic operations and spatial object manipulations. So I was hoping by the end of this webinar, you'll be able to build an interactive map, and visualize population density for a parish in Uganda and demonstrate Python's capability for spatial data storytelling. Let me tell you an example of, let me show you an example of what I mean by this interactive maps. I had one here that I produced as I was preparing for this webinar. So as you can see, this is what an interactive map would look like. So what do we mean when we say interactive? It means if I click on, a particular polygon, it's able to display for me the information that I wanted to be displayed about that polygon. But this polygon is, the parish is called Ogwanga Chuma. The population density is there. The district is called Kole. So this map I produced, they are called Toropleth maps. This is a population density from data that was done. I think a census was done in 2016. So that's the data I used for this. So this is what interactive maps are all about. This you can embed on your website. You could share to someone anywhere in the world with the link. So if I zoom in further into Kampala, it also has a scale bar here, which is not so clean. I think I had an oversight there, but it's supposed to show you from low to high. As you can see, the more dark ones show a higher population density than the lighter colors like this. So if I have a parish in Mpigi district that has a population density of 118 in a parish called Mbazi, And if I go to the one in Kampala, we have a parish called Chebando with that population density of over 14,000, you know, in the district of Kampala. So this is what the interactivity is about, yeah. And you can see if I zoom in more into the map, even the parishes are clearly labeled and you know, villages and everything. That is what interactivity of this map is about, and that is what the power of Python could, you know, present to your problem solving and everything. So let me go back to the presentation and rush through it. So how do we then, you know, load shapefiles with GeoPandas? We're going to look at that, how we can load shapefiles with GeoPandas. And then we shall look at how we can inspect and clean the data, you know, how we can rename fields for clarity, how we can drop unnecessary fields, how we can, you know, do any other data manipulation thing that we need in ArcMap using the GeoPandas. We need to learn how we can enhance the data structure for analysis. How do we get to calculate population density, you know? How do we change between coordinate reference systems? How do we derive geometric properties? How do we produce a static map with matplotlib, you know, basic choropleth plotting, or any other static map, how we can export it, how we can customize visuals for clarity. We shall also produce an interactive basic map with Folium, like the one I just showed you. So I will also share, I think, this notebook with you after the training, so you could just, you know, simply follow through if you get lost. Interactive basic map visualization with Plotly, exporting and sharing your maps, you know, and that other last bit, which is on the final thoughts. That we say we have embarked on a comprehensive journey to transform raw spatial data into compelling visual narratives. We're going to look at GeoPandas for efficient loading and cleaning shapefiles, ensuring our data is analysis ready. And then we can move to crafting static publication quality maps using Matplotlib, and we progress to build interactive maps with Folium, Plotly, and the rest, you know. And then you can look at how you can expand your geographic horizons and every other thing. So I have a link to my GitHub repository that I have shared there, which you no. This is a private repository. For my GitHub, it is a private repository, so I'm not sharing it. So this link is not a valid one. But I have placed a link for the Google Colab notebook in the slide. So once I share the slide, you'll be able to access the notebook through this link. But for the GitHub repository, it is my private repository, which I don't intend to share. Okay, now let's go on to Google Colab and start. If you had the intention to, you know, do this practically with us, this is the time that you could, you know, go ahead and do this practically with the rest of all of us. Now, Python
just a quick one.
Okay.
Guys, Google Colab is a free tool. It's online. You can just go in your Google Chrome, put in Google Colab. You'll like sign in or sign up like any other, maybe as you use it with your Gmail, and you can access this platform. So just in case you're wondering where this is, please, your Google is enough. Your Chrome is enough to have you get this tool. Thank you.
Okay, thank you, Arthur, for that clarity. I believe I mentioned earlier to the team on the WhatsApp groups that you should have signed up for Google Colab. It's a free tool, and GitHub as well. Yeah, you should just go to your browser and search Google Colab. You'll get a link to sign up, and you can use your Google account to sign up, or if you have GitHub, you can use that to sign up, or you can as well use your email and create a password or something like that. So this is what a Jupyter notebook library, oh, sorry, a Jupyter notebook would look. I'm seeing someone has reacted with a worried emoji. Well. Okay. Please do not be worried. Yeah. It is very, very easy to learn Python. And with the advent of vibe coding, there's nothing that could really defeat you. You know, vibe coding is for vibe coders, it's not necessarily people who do not understand a language or how to code, but you leverage AI tools to help you, write code, debug your code, and everything. But the disadvantage of vibe coding is that when something fails or something does not go right, it will be very hard for you to debug. To debug is to find what is causing your your code to fail or not to run. Yeah, that is what to debug is. But the reason why I chose Google Colab for the webinar is because it has an inbuilt AI tool that helps you suggest code. It could even help you write code. It is allowed to use AI. You could use Gemini, you could use ChatGPT, you could use a code editor like Casa that uses, AI to write all these things. So don't be worried. It is okay to Google things. It is okay to use AI when you're learning to code. It is okay to do all those things, yeah? So I don't expect the worried emoji reactions to be coming up so much. Yeah? So let's move straight into the, the practical bit, of course. Since people are now very worried, I hope I don't take so much time on this. But the thing with Python is just once you learn, there are a few things that you should have like at your fingertips if you're trying to learn Python. And there are quite a number of YouTube videos out there. So AI that you could ask teaching Python. There are quite a number of free tools out there that, you could also use to learn, Python. But you need to understand lists in Python. You need to understand the different functions within Python. You need to understand how to declare a variable, how to, call a function, how to write just you need to know the Python syntax, the indentation, at least the basics, so that even when you vibe coding and something fails, you can easily tell where it went wrong and then, sort it out. And even if still something goes wrong in your learning process, or even if you're now a seasoned, coder using Python, it is still okay to use AI or Google things on how to solve your, or how to debug. We use the term debug. A bug in programming is basically just an error that is in your code. That's what they call a bug. So the first thing you have to do, of course, if you're now going to use a tool like Google Colab for your cartographic project, is you need to install and import the necessary Python libraries that you want to use. We looked at Python libraries that are necessary for cartography, the likes of GeoPandas, the likes of Matplotlib, the likes of Folium, Plotly, and Shapely. So if these libraries are not yet installed on your code editor or your platform that you're using to do the coding, you have to go ahead and, install them. So let me just briefly open a new notebook. So a new notebook in Drive. And I want to show you how powerful this Colab can be for even your learning, process, and how easy it could be. So that we do away with the worry that people are having. Yeah. So now, as you can see, this is a new notebook, a new Jupyter notebook that probably you have on your screen as well. Yeah. And you see it's even untitled. So I can go ahead and name maybe my notebook, and I say this is a training 2025, you know. Another thing with Python is that code is run line per line. Yeah. Code is run line per line, and in case maybe there's an error in a line, it's of course now ends there and does not run the lines down. So here we are trying to import data into ArcMap, which is into our Google Colab project. So the first thing we shall do is, if you look on the left, we have all these icons. Let me just click on them and expand them. We have files, we have code snippets, we have secrets, and we have this. Yeah. Now what you do is, if you do not want to run a line of code directly in your cell to upload your data, you'll just come here and upload something to the session. Yeah. So then you'll go to your folder that has the shapefile. For this case, we are using the population size and headship of households. You have to pick every file that is related to that data. If you only pick the .shp, of course, nothing will render. So shapefiles come with all these other files. So I'll just pick all of them and open. And it tells you, ensure that your files are saved elsewhere. These runtimes files will be deleted when the runtime is terminated. So the thing with Colab is that this gets deleted once you terminate the runtime. Yeah? That's why I told you it's necessary to have a GitHub account so that you can always push and save everything on GitHub. So now we have the data sets here loaded into our project, and we have the .shapefile here. As you can see, the .shp and all the other files that are necessary for it. So now let me show you the power of AI. You can even see it says start coding or generate with AI. Now what do? I'll comment. A comment in Python is like is something that tells you what you are trying to do in case you came back later to look at your code, maybe read it and see what you are trying to do. So here we are trying to produce a static map and produce an interactive map also. So the first comment I'm going to do is we are install and import necessary Python libraries for cartography. Yeah. So a line that starts with a hash in Python is a comment. So it does not get executed when you run your script. So if I click enter here, and I have said install, and here we are trying to install and import necessary libraries. Yeah. So, but since now I have everything installed, I will not have to reinstall them again. But if I had to install something, you use the pip to install in Colab. You see, once I do that, it has already suggested every library that it thinks I might need. It has suggested install pip install GeoPandas, pip install Contextly, import GeoPandas as GPD, import Contextly as CX. That is the power of the AI. Just a moment. All right, let's proceed. So sorry about that. As you can see, it had suggested for me every library that I needed. Yeah. But since I have them installed, I do not have to repeat. What I'm going to do is to simply import. I'm importing GeoPandas as GPD. I'm importing matplotlib as PLT. I'm not going to use contextly here, so I don't need contextly, but I can simply press tab and have this all in. You see, contextly is underlined because it is not installed and I've not used it here before. I just want to import folium instead. Yeah. And then I can run this code. You can click this icon to run your code and it gets executed, and you'll see a green tick once everything is properly executed. And you can go ahead and continue writing code in the same cell, or you can create another, cell. And now say the next thing I'm going to do is you comment so that you can get reminded. I'm going to read my imported data. Yeah. So if I'm going to read my imported data and I'm working with data that is called population size. So what I'm going to do is say population size is equal to, you can see AI is automatically suggesting everything for me. Yeah. That is how powerful these tools are, even if I am not so good at coding. Once I type this, and once the AI will detect what comment I have put, and it understands what I am trying to achieve in that cell. I'm trying to read the imported data. But now, my data is not called population size.geojson. I have a shapefile that I'm working with. I'm not working with a GeoJSON file. Yeah? But the function that we call to read is a geopandas.read file. That's what the function is called. Yeah? So if I press tab, it automatically inputs that line of code for me. But if you see from my imported data that I have, my shapefile is called population size, blah, blah, blah. So I have to come here to these 3 dots and copy that path, Once I copy that path, it is what I am going to replace here because it's the data that I want to be read. Yeah. That is the data that I want to be read. So if I click run, and now the notebook has read my data and I can now access it within the cells that I have here. So to see that I have actually now imported the data, let me go ahead and view, the first maybe 5 lines in the rows in this data. I can comment and say, I want to view heads here. Yeah. Don't worry if it sounds like, I don't know, magic to your ears right now. If you take time and try to learn the basics of the Python before bringing yourself to Google Colab and you now want to, do something with it, you will understand it much better. For now, just be there, see what can be done, and you can perfect your learning later. Yeah. And as I mentioned earlier, you can as well vibe code your way to everything you want to do. So if I'm viewing heads, AI is automatically detecting what I want to do and is saying, I have named my GeoPanda data frame. If you've worked with pandas, you know that we declare, we have data frames. We convert our data into data frames. But now for GeoPandas, we use GeoPandas data frames, not pandas data frames. So it's saying population size dot head. That's the function that reads and gives out the first few lines in that data. So if I run that, I'll see the heads, the column names are there. The column names are there. And these are the column names that we have. Then we have the first 5 rows that Python has displayed for us. If you want to view more rows, you can, of course, inside these brackets, you indicate the number of rows that you want. If I want the first 10, I will indicate 10 inside that, and it will present everything. But now if you look at this data, yeah, We have a column called GID, we have a column called object ID, then we have D, C, S. These do not all make sense. What is D, what is C, what is S? You want to have your data in a way that makes meaning, yeah? And we have several other columns that are really useless if we are trying to just produce a static map that shows population density. We have columns like PNAME, which is of course parish name. We have PNAME, which is parish name. We have MPOPN, which is male population in that parish, then female population in that parish, sex ratio, total population that was recorded. So you can see we do not really need some of this information. All we need is, we need the parish information, of course. We need, if we are going to do a population density for only the female population, then we may not need the other information also. If you're doing the total population density for the total population, we can go ahead and drop the other columns that are not necessary, like these columns that do not make sense, FH head, percentage FH head, and every other thing. You can drop some of those. And then we have the geometry information at the end here, you know, and every other thing. Okay, I'm seeing the attendance dropping. It has been 70 something, now it's 63. People are getting scared and running away. But please do not be scared. So now this is where you go to, you know, analyze and now clean your data, yeah, and everything. You want to now start renaming some of these columns. You want to drop some of them, you know. Then you want to maybe calculate other new fields. If I want to do population density, I know that population density, the formula is I will calculate the total population and divide it by the total area, yeah. So you can do all that within Python. It's also possible in ArcMap, though we didn't look at it since we didn't have population data or any other data that you would want to use to produce a short map, yeah. So let's get back here and say, now that we have viewed this, maybe I want to see also how many columns are there in this data that I've imported, you know. View columns. AI is going to say population size dot columns. If I run it, it will show me the number of columns that are there. I have a column called GID, blah, 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 and every other thing, you know. What if I wanted to view the description of the data that I have, or the info? Let me just view info. Yeah. Let's see. We have all this information. We have a total of 22 columns, you know. The data types are indicated there. We have float, we have geometry, we have integer, we have object, and everything. But you get to understand all this with time as you understand Python, yeah? But for now, for the demonstration purposes, for the purpose of the webinar, just evade yourself with a learning mindset. Be open and try to grasp as small. Even if you live here, knowing that the first thing I have to do is install and import necessary libraries, you would have learned something and gained, okay? So just pick something small you want to learn. Even if you're just living and you've said, hey, there's something called Python, which is not a snake, but a tool for data analysis. That is enough for your learning today, okay? Right. Now let's go ahead, and we have seen what we have. We have columns, we have some of them with names that are quite abstract and do not make meaning and blah, 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 yeah? For the interest of time, you know, Arthur has not yet mentioned it, but it's already 6, and we had intended that the webinar stops at 6. So I'm just going to go to the notebook that I used when preparing for this webinar and take you through using that. As you can see, I imported necessary libraries, and then I read the files. Then I viewed the info. Yeah. I went ahead and viewed the info. I saw what was necessary. I viewed the head. I saw what I needed to change, what I needed to, you know, do away with. The description gives you statistical, you know, information about the data set. Gives you the count of data, gives you the mean, standard deviation, you know. the mean value recorded and the maximum value recorded and everything that you can have there. So now I want to confirm the coordinate reference system for this data that I have. All you have to do is .crs, whatever. If this was a geodata frame, you just call this maybe gdf.crs, and it would produce your coordinate system. But since this, I had declared my data frame and called it population size, population size, yeah, .crs, and you click run, it runs and shows you what coordinate reference system you're working with. Yeah, you're working with WGS 84, UTM zone 36N, and blah, blah, blah. It gives you the easting, the northing, the area of use, the coordinate operations, gives you UTM zone 36N. The method is a transverse marcator. The datum is the world geodetic system ensemble. The ellipsoid is there. The prime meridian is there. Assuming this was a CRS that is not correct for the data set you're working with, you can go ahead and change the CRS to match the one of Uganda. Yeah, you just call a function called to CRS. As you can see, my data frame is called population size, and I'm saying population size is equal to population size dot to CRS, which is a function that changes the coordinate reference system to one that is correct, EPSG 32636. But since this, I had already changed this and it's giving us the correct one, it's of course not going to do any much change to us, but you would specify what CRI system you are working with, Apple. And then you check your new CRS and get it. And then you can go ahead and rename columns. We saw that some columns were called D, others were called C, others were called blah, that were not really making sense. Yeah. Now you can have your line of code to rename. There's a function called .rename. As you can see, whatever you'll see after the population size dot is the function that we are calling to, perform the task that we're trying to achieve. So here we're trying to rename some columns. Population size dot rename the columns. We want to change from this one. It's not, we want to change it from D to district. This one was C. We want to change it and call it county because that was meant to mean county. P name, we want to change it to parish name. MPOPN, we want to change it to male population and blah, blah, blah. So that's how you could, do that. But still, I told you, the moment you declare the intent of what you want to do, and just by simply commenting and saying, rename columns, AI is going to even write for you at least a rough code to rename some columns that you want. Then you can edit and customize it to what you want. That is if you're not so adept with the scripting language. And then now you can go ahead and you just simply run and it gets renamed, and you can go ahead and, view the names of the new columns that you have. You can see now they have changed. We have district now. Up here, we still had, D, C, S, and the rest. But now down here, since we changed some of the names, we now have columns called district. We have columns called county and the rest. Yeah. Then we want to remove unnecessary columns. Remove columns that, not necessary for our analysis, like all these other ones. If I simply run, and now, this is very good. We now have a bug that we have to resolve here, because if we don't, this line of code that has not been executed is going to affect the entire, other lines of code that we have down here. So if you go and read the error message that is given to you, this gives you the information that you want. Even if I am so lazy that I can't read through the error message to see where the problem really is, I'm having a keyword error here, or a key error. It's saying all these column names that I've indicated were not found in the axis, meaning either I've already renamed them, or I have maybe already dropped them or something. Yeah. You can just go ahead maybe and copy your entire error message, paste it in AI. AI will explain it to you and tell you what to do, what to change. Or you can simply, if you understand the logic of the scripting language, you will go ahead and, look through line per line and see, what needs to be changed where. For the interest of time, let me just comment this out. If you comment something out, it does not get run in Python. Yeah. So then we can print. I printed the new population and everything, I removed other things. I viewed heads again. Now I went ahead and calculated area here. I added a column called area, and I used it to calculate area of the polygon in square kilometers. The line of code that I wrote is that, population size area is equal to population size geometry dot area divide by 10 to the power 6. Now this slash sign in Python is a division sign. Then if you have 2 asterisks or those stars, it's like 10 to the power 6. Yeah. But these things, you learn them eventually if you take time and maybe join the training with Gyro Solutions, or if you take your initiative to learn Python on your own, and you get to understand everything. So then we calculated area because we calculated area, yes, because we know we need the area information to calculate population density. We did not have area information in our data set that we have. So now, as you can see, now we have a new column called area here. Yeah. A new column called area, and even a new one called population density that I had already calculated, which is there. So we have brought up 2 other columns. And as you can see, it is much easier to do these calculations in Python by just a single line of code than in ArcMap, the way we did it the other side. So the other thing is now to plot a basic map. This is a static map. Plot population density using matplotlib. And you see the initial map that we are given is just something that looks like that. Doesn't really make meaning. It does have the grids, but the color is, consistent all through. It's all purple and doesn't differentiate like the other first map, the choropleth map should look like, since we are trying to show information about population density. So that means we have to write a different line of code to classify, the colors, to make sure we come up with a proper choropleth map to demonstrate what we want to, come up with. So now we want to customize visuals for clarity. We install map classify, which is another Python library. And then we import it and we write our lines of code, which for now, definitely, I believe will look like magic, but don't let that discourage you. And so once we do all those and we run, it produces for us a much better map now that actually looks like what you're going to see on the screen. Now, this is a much proper choropleth map showing the population density per parish. As you can see, just with a simple line of code like this, we would have done a lot of things in ArcMap to be able to produce something like this, to produce your map, blah, blah, blah. But here we've just written about 5 or 6 lines of code, and we have our choropleth map that looks this neat. You see the darker ones show higher population density. The lighter ones show lower population density, but still you want to probably now customize your map to, look much better. I'm seeing someone saying they've liked it. You're welcome. Python is interesting. Once you get obsessed with it, you might be sleeping at 4 a.m. every night, just trying to learn or trying to write something. But we want to make this map look much more interesting. You maybe want to add now a scale, you want to add a proper title, you want to add key, north arrow, blah, blah, blah. Simply, you just have to write the line of code, to produce that. If now to save our plot, you write the, line of code to save. If I run this, it will save a file here in my, I have said it should call the file population.png. If I want a JPG, I can say, call it saver.jpg or saver.tiff or whatever I want, and you specify the dots per inch that you want, the bounding box inches, height, and every other thing, the quantiles. Don't be discouraged by all these terms. Learning takes time, and you will get to learn this eventually if you put it to your heart that you should learn. Now, if I want to see the plot that I have saved, I can simply go to, files here, and I'll see that I have a .png here that I can simply go and download, and that is it. That as simple as that. Just a line of code, and you have something downloaded. You can see I have a .html also here, which I did run. Of course, that is to save an interactive map. The interactive maps are saved in form of HTML files. So if we proceed down, now that was the beginning part of static maps. That is how you create static maps in Python. You could customize it to look much better if you want to add other information, if you want to add a frame to your map and everything. You just have to write the line of code. Now, for interactive maps, we use Folium. Yeah. As you can see, this map is interactive. You can zoom out the entire world, and I have Uganda here. But now we have to add, create a Folium map centered on Uganda. For the Folium library, you have to know the approximate center of, maybe if you're trying to do an interactive map of Kampala, you have to know the approximate center of Kampala in terms of latitude and longitude. You can simply just Google this, or you can ask AI, tell me the approximate center of Kampala in terms of latitude and longitude, and AI gives it to you, and you come and insert it in your line of code. So you create a Folium map centered on Uganda still, that line of code. So now what the zoom start, which is 8, determines where the zoom of your interactive map will start from. If you have a lower zoom start, your Uganda map will look much smaller. If you have a much larger zoom start, once the program runs, your interactive map will show what you want to be, or a larger view. Yeah. Then you can display the map by just simply saying Uganda map, and it gets displayed. So now we have this interactive map displayed. But we want to add information about population density onto this interactive map that we have displayed here. We import another library called branca.colormap. And assuming the Uganda map is our Folium map object from the previous steps, now we define the color scheme that matches what we have in our static map. Then we here I've used 9 classes for a good range. All this information can be Googled. You don't have to have it at the back of your mind, yeah? Of the color schemes and everything. Then you can classify the population density data into quantiles and every other thing. Then you create a linear color map using Branca. Define the style function to use the color map. You go ahead and add the geodata frame to that interactive map that you're creating, coloring by population density. And this is the line of code that does that. Yeah. And then at the end of it all, as long as you press run, boom, the magic happens and you have an interactive map. Yeah. That you can share to maybe your senior administrators at your company, whatever stakeholder, and they can, whoever has this HTML file can, interact with the map. You can host the .html online and then share that link, or you can embed this in your website, your company's website, to maybe show, if you want to maybe create, even if you just want to create a project, an interactive map that shows location to your company and embed it in your website. Python can help you do that, Now, if someone interacts with this map, they can go and see, what's the population density in, let me see, in Kololo 3, a parish in Kampala. They go and say, this is 990.276. Okay, let's go and see maybe somewhere in Karamoja, what was the population density there, Someone comes up and looks at Karamoja, Kotido district. There is a parish called Nakwakwa, with a population density of 36.43 and everything. So as you can see, that is simply the interactive map and the static maps and how they look in Python. I've not looked at the other libraries like Plotly and everything because of the interest of time. I would want to stop here. I'll share this notebook. I'll share the slides that I used. And yeah, as we mentioned earlier, for those who would want to learn much more, you will get in touch with the team at Gyro, and we have the solutions engineered to your interests. So I hope we have learned something and we didn't waste each other's time today. I would want to thank everyone that has been a part of the training. I hope it has added value to you, and I hope it has sparked your curiosity that you want to learn Python more, or that you'd want to learn how to, digitize maps with ArcMap later more, or any other tool that is out there, These are the skills that are necessary in the industry, whether you're an earlier career engineer, whether you're a student, whether you're a seasoned professional. If you have this skill set, they might as well ask you to increase your salary, because they will not have to hire another person to, produce maps or solve problems with location information at your company or something. Thank you so much for being around, and feel free, of course, to check out my LinkedIn, follow me. I do post a lot of useful information there, and well, I'll give you back to the Managing Director of Gyro Solutions, Mr. Natkunde Arthur. And have a good evening, everyone. And I'm glad you are a good audience today.
Thank you, Raj. I hope everyone has enjoyed. I think I love the Python part. It's the part where I started, I think, my coding career almost way back in school. And yeah, pandas and Python, like Plotly, NumPy, you're like everything you need. Because rocket science. Now, when it gets, just a minute, I think when you switch the confusing,
Arthur, you're not so audible.
Okay, can you hear me?
Yeah, that's much better.
Okay, I'm using another computer, I think, to project my voice. Thank you, Raj. Hopefully it has been a good presentation to everyone. And we are going to upload this on YouTube, and we shall share the link on YouTube, on the WhatsApp group. And to any of you who has picked interest in Python, ArcMap, GIS, this is just the start. We've just scratched a little bit of everything, because this takes me back way in campus when I was doing analysis on, I remember it was the Equinox or well data sets, and everything at the first glance, they look really awkward and hard until you decide to make your fingers dirty and learn something. And I can't fail to appreciate my team. A team of young guys who have reached out to you guys, a team at Cairo. Thank you guys, we've pulled this off. And I've shared a link. Make sure that you register on the link, and so that we can work out your certificate and share it to you. And those who are interested in being geniuses on this thing, or you are a student and you're looking at your final year project and how you can make something really amazing with the data, we've created an extensive training, and we have shared it to everyone to the link. We've shared the link. Those who have registered and have interest, we shall be only paying $100. That's 370,000 UGX. That's not something much. to invest in knowledge and a skill you know which will earn you more money out. Uh, at this point, I'm going to allow a few questions which will come through. And in case you have any other more questions, shall take them on the WhatsApp group. We're going to open up all the WhatsApp groups so that we can have that interaction. That way we can help each other grow. We can create a community around ArcGIS, ArcMap, and Python so that we can be better with time. I'm seeing a sound, John Calvin. Anyone who has a question, please just raise up your hand. I'm going to pick a few questions and then we can get going. So first, see the sound. Yes, Sangu, can you open your mic?
Okay, thank you very much. Are you able to hear me?
Yeah, we can hear you.
Yeah, thank you very much. My name is Calvin, and I am so excited for this new knowledge that is trending. I've learned a lot, and I hope to learn more. I equally do a lot of GIS work with various institutions and especially in disaster analysis and environmental conservation. So I just an inquiry, and this basically goes to this question goes to Ronia. I don't know if she's still online. She talked about the chambers. She talked about the chambers, and so my question is, how can we join these chambers? And what does someone need to join the chambers? And then let me just choose a few questions. I have quite very many here. The second question goes to Paul. Paul, thank you very much for the practical part of it. For the hands-on, I think we will learn a lot as time goes on. Now, you talked about use of base maps. I believe in the Petroleum Authority, we should be able to have this kind of information. We do understand that base maps that are embedded in ArcGIS, some of them are a bit outdated. They are not up to date. So I'm wondering that maybe as the trainings go on, you can also take us through maybe georeferencing a base map that comes from Google Earth. For some areas, I do think they are quite updated. So that is 2. And then 3, I have seen in this certificate link that you posted, there is a section on payment. I would like you to be specific. What kind of training is this? Would you please provide information on the content of training? What kind of game? Talking about that still advancing in Python and incorporating it to the GIS, or there are quite some other elements. So it would be better if you really be clear on, be specific on the kind of training that we are going to pay for. Lastly, Ronia talked about trainings in Kabale, Tororo, Gulu. Why are these trainings customized to only these districts? Because I'm seeing Kabale, Tororo, and Gulu. Why are you holding trainings in these specific districts? And if so, the trainings in Kabale, Tororo, and Gulu, are they the same trainings that you have asked us to pay for? They are $100. So are the other ones different trainings? And is this very one that we are paying for, is it a different training? So you also need to be clear on that. Otherwise, I am really so happy and very grateful, and I hope to learn more from the Big Solutions group. The other one I had, I don't want to talk about it here because it is a training that we also do somewhere, and I wouldn't want to talk about it here. Maybe if you give me an opportunity, I can display what we also do. Otherwise, but the other part of it is that the training looked to be capturing people who have never interacted with GIS, but I think there are some features that really needed some basic GIS knowledge, like georeferencing and coordinate system digitizing. that really needed some kind of prior training. Otherwise, thank you so much. Big ups.
Thank you so much. Before I get to other questions, I think let me first attempt this before I lose track. So first, how can one join the chamber? The junior chamber has a registration link on the website of the chamber, ucem.ug. You just put it on the browser, www.ucem.ug. You check under About Us, and under About Us there is a link, a tab called Junior Chamber. So you just get there. There is a link where you can register, and she will be able to reach out to you. Now, if you have a company which wants to join the main chamber as a member, still it's the same protocol, but we can forward your details and your everything to the membership officer of the Uganda Chamber of Mines and Petroleum. Uganda Chamber of Energy and Minerals. So the reason as to why actually I'm attempting some of the questions for Ronia is just dropped off the call. Then to be specific about the training is still, we are going to provide the training about GIS and Python. So that's the package we are making. And for any other more information, we are going to reach out to the people who have expressed interest with very specific details and customized to what we are basically providing. Then the trainings we are having, which are in the different locations with the Junior Chamber, they are in partnership with EU and GIS, and those are free across Uganda, and the locations were picked basically up because of the reason or the need that we need to cover the whole country. Most of the trainings we've been having have been centralized around Kampala, and the Junior Chamber and GIZ and the EU are looking at how can we cover the whole country with the different skills. And the different locations you've heard are in different universities in those locations. So I believe I've answered the questions you've raised. The basic skills about GIS, I think that I'll leave it to Orach. If we can attempt 2 or 3 so that we can have other questions. Thank you. Okay, Isagu John Calvin, thank you for your questions. You asked a question about georeferencing base maps from Google Earth. Well, OSM, which is OpenStreetMap, has a number of collaborators, and they are frequently and constantly improving their data sets. They have, I think, almost monthly or even weekly contributions from all around the world. And I would believe for base maps from OpenStreetMap, they are quite updated. And still, for the ones you want to reference from Google Earth, Python is a powerful tool, yeah? You just have to learn how to write the lines of code to pick a base map from Google Earth. And then you can have that working for your convenience. The other thing he asked about is the content of the training to be paid for. Now, what we do when it comes to solutions engineering is that now that you are the client or the customer, you present us your pain point. If you say you want to start using Python to, automate some of the repetitive tasks or your geospatial analysis tasks at your farm or even as an individual, and then now we get to be the architects of that solution. We customize a solution to your specific need. It is not that we have ready-made solutions out here waiting that this is the training that we want to provide. We are dynamic, yeah? Whatever problem you're coming with at us, we are going to engineer a solution for it. So that is what I can tell you about the content of the training. So whatever you said, you're into disaster planning and something like that. So if your problem or your pain point is around that, we get to, you know, tailor a solution that is in line with that specifically. All you have to do is reach out to the team at Shiro with your pain points, and then we can get to, you know, see how best we can tailor a solution to your needs. Thank you. I think we can have other questions.
Thank you. Do we have any other question, or we can call it a day?
Okay, thank you.
I think we don't have any other question. I had seen another person. But it's okay. We are late. 5 minutes past the time we had agreed to have this training done. Thank you, everyone who has joined, and it's been an honor and making this day count and this training count. Hopefully, we have really added something to you. We have really, I think, empowered someone or given someone some knowledge. Thank you, my brother Orach, for this insightful training. Thank you, the Uganda Chamber of Energy and Minerals. And thank you to the Junior Uganda Chamber of Energy and Minerals. And from Cairo Solutions, thank you all. Bye-bye. We are going to provide a form, a feedback survey where you can give us everything you need or what you would love more to learn about. And make sure, please, you fill in that link so that we can share your certificates later on. From me to you guys, bye-bye. Thank you.
Thank you, Arthur. Everyone have a wonderful evening, and we are glad you were part of this.
Yes.